Who feels very sleepy after lunch? Me, definitely. Who? How many people, actually? Yeah, how many people? Okay, just 4 people. Yeah, that's good. Yeah, let me start with something very quick because I forget. I want to say thanks to Analytics Video, and I really mean it. It's been a while we're collaborating together. We did a course about CrewAI. These people are crazy. I love them, and I'm really grateful to be here. This is my first time in India. Please, thanks. And I'm really excited. I'm really excited. All right, so today I want to talk about LLMs and Agentic AI in general. My take about Agentic AI is the take of a software engineer. I work as a data scientist, but I really want to give you an understanding of when you have to use this stuff. There is a lot of hype around Agentic AI and agents, and a lot of people ask me, okay, is this true? Can I actually do something real with this technology? And this is my take. I'm not a marketing person. I'm not a salesperson. All these things you're going to see here are basically open source stuff, and I'm a builder. I like to build stuff. I like to build stuff that hopefully will work one day, and this is about building something. We will start with a bit of history, compound systems, LLMs, how we got to the point of talking about agents. We will dive into dynamic systems. I'll explain what is it. We'll talk about the reasoning, MCP, and then I'll show you CrewAI. Who knows CrewAI here? You're all experts. I think we don't need this presentation. You're all experts. I'm really glad that some of you know this library. We will dive into the basics of this library. And by the way, I'll do a workshop on Saturday about it. We will look at a very simple use case and then a more advanced one, and I'll show you a demo. So this slide is usually for the audience, that kind of audience that doesn't want to engage. You guys always want to engage. So I usually, when it comes with this slide, I say, hey, I'm really approachable. I work as a data scientist. If you don't want to talk about data science, we can talk about something else. But there's no need to do this here because you guys are amazing. You already stopped me many times. We had a lot of chats. In a nutshell, I work as a data scientist. I'm a software engineer. I've been exposed to many different domains, namely automotive, ride-hailing. I was at FreeNow, and so far, so on. And apart from this, if you hate data science, we can talk about music later. We can talk about sports, many different topics. All right, let's move on. A bit of history. 5 years ago, this is a very strange way of telling what happened because we're talking about recent history. 5 years ago, kind of the world changed and also my world because ChatGPT was released. And a lot of people, to the consumers, and a lot of people were amazed by the things that we can do. And how many of you think that ChatGPT was released ages ago? It seems like we did this ages ago, you know? Like when we talk about RAG, we are talking about something old. No one wants to talk about RAG anymore. We want to talk about agents, cool stuff. RAG are for boomers, for old people. This is what I feel. But in the end, everything started in 2022. 2022, we started working with LLMs. When we work with LLMs, in a nutshell, we have a query, we have a generation step, and then we get an answer. The generation step is based on a model that has been trained on some data. And what's fun about this is that, I don't know if you remember when ChatGPT came out and people were making fun of this service because they were saying, hey, look, how many screenshots about that? They were like, hey, I asked ChatGPT who is the president of the United States, and it failed. It said something else. Who remembered this thing? And I was like making fun of ChatGPT because didn't know stuff. You know, I was doing the same. A lot of fake influencers on LinkedIn, they were talking about this stuff like it was funny. For me, it was not funny. It was actually meant to be like this. There was a system that didn't know anything about the recent history, the recent data. And what happened afterwards is compound systems. When we talk about compound systems, we're talking about RAG. So essentially, we still have a query, we have a generation step, and we have a RAG. With this RAG, we are basically telling the LLM that there are some data that the LLM can access in order to answer questions. And this is a really nice trick. We have a vector database. We don't want to dive into details. In a nutshell, the LLM can access more information. One example is I'm asking the LLM where I'm going on vacation next week. The LLM doesn't know anything about it. But if we give it as a vector database, the LLM can access this information. And then we have agents. When it's about agents, what we're doing is essentially implementing the reasoning. We will dive into the reasoning just to explain that reasoning doesn't really mean reasoning in terms how human beings reason. There is a huge debate about it, and maybe we don't want to start this debate here. But in a nutshell, when we talk about agents, we're talking about an LLM that is the core thinking unit of this agent. We're talking about some tools, and the agents can decide when to use the tools. And then we have the tasks. The tasks are what the agents are going to do. And we don't get the direct output from the LLM, but instead we have some sort of reasoning process that is looking at the output and deciding if it's time to give the output out to the users or not. It's pretty much what we do. If I ask you something, if I ask you, hey, help me with this information, how can I solve this problem? You can give me a very quick answer, but you can also think 10 seconds, 20 seconds about it, and this is what the reasoning is about. This is what we do. And of course, the more you think, I hope, the more the answer will be correct, hopefully. All right, so agents versus dynamic systems. Why do we talk about agents? Agent, for me, is not a new concept. I was studying agents years ago. And when we think about agents, we always have to connect them to dynamic systems. And this is the key point that is missing, I believe, when people talk about agents and they don't know when to apply agents. And this is how many people have this question. How many people say, when do I have to apply agents? Me included. I mean, this is tough. I get it. I mean, don't be shy because this is a problem. And it's not the first time we're trying to solve this problem. This was happening also when we were talking about deep learning, machine learning. How many of you struggled back then to understand when it was the case to apply machine learning? This is nothing new. What happens here is that we need to remember that we apply agents, we use agents when it comes with dynamic systems. Whenever we have a system that is changing very fast, that has a lot of constraints, and we're trying to optimize something. One example is, let's say we want to go from A to B in Bangalore, which is going to be tough anyhow. But I know from experience. We want to be from A to B. We want to go from A to B. And then I ask some of you, someone who knows how to write code, a simple algorithm. You can look at the map and say, okay, you go left, you go right, and you give me some sort of routing algorithm. This algorithm is a deterministic algorithm. It means that once you have it in production, it's there unless you change it. But if something changes in the system, because it's a dynamic system, you have new constraints, you have new signals, this algorithm will fail. And it's fine because it's a deterministic algorithm. But we're applying this algorithm in a dynamic system, and things are changing very fast because it's dynamic. But if we build an agent and we say, I'm not telling you what to do exactly, I'm telling you, try to go from A to B and you decide what to do. I give you some instructions, but then if something pops up, you decide what to do. And thanks to the LLM, now we can do that because we have a thinking process and the agent is like, hey, I'm an agent that has to go from A to B, but if there is traffic jam, if there is a cow in the street and everyone are blocked, we're going to move away and I know how to do it, you know? And this is the beauty of using LLMs into agents. The agents family, just to give an example, we can have expert systems. This is not new. We had expert systems some time ago. Perhaps if you're as old as me, you remember. Who remembers help expert systems from? Okay. I am old, indeed. Anyhow, reinforcement learning, AlphaGo. Do you know AlphaGo? AlphaGo was an agent. So AlphaGo was actually using deep Q learning agents and not an LLM, but still an agent. Why do we call it agent? Once again, because it was it was actually walking into a dynamic system. And based on the input, it changes the way it works. We have the simulations agents, we have crawlers. So agents is not something new. So why now? Why are we talking about agents now? Why is it so famous? And most of the times we talk about Agentic AI. Well, the reason is LLMs. Now we have LLM, as we said, as thinking process. And with the LLM, we can let the agent reason about something, interpret the system, the dynamic system, chain decisions. Perhaps something happens, we need to stop in the traffic, but we can take another route, and the LLM will decide if it's the case or not. And then we can communicate naturally with the users or with other agents if we have the right protocol. Now the reasoning, I'm mentioning this many times, and some people get upset when we talk about reasoning. I don't really care too much. This is all mostly for my lawyers, in case someone is complaining about me talking about reasoning. No one is reasoning for real, but we don't know how we reason. I mean, if I ask any of you, like, can you explain me how you reason, we will probably give different answers, and this is completely fine. I mean, we're still in the process to understand how we reason. Some time ago, when we started working on deep learning solution, I mean, the terminology neural networks came from the neurons. But then we understood that this is not how we think. It's completely different. But for historical reasons, this is how we call them. So we have these neurons, but it's not how we work. So reasoning is more for you to understand, okay, the reasoning is a word that we use because there is some loop. You can see it as a loop of multiple LLMs trying to understand what to do next and then take a decision at some point. And we can call it reasoning or whatever you want. Of course, there is a huge debate because there is a famous paper from Apple saying delusion of thinking, LLMs are not really thinking. I'm fine, I'm an engineer, I don't care as long as they do what I want them to do. I'm completely fine with it. But it's a really interesting topic. What I wanted to give you with this slide is this ARC. These are the real benchmarks. The benchmarks are not what you see on LinkedIn, what you see from some influencers saying, hey, look at this, my LLM now knows how to do this A, B, and C. That's not a benchmark. The real benchmarks are done with this kind of models. These are models trying to understand if we can generalize patterns with the LLMs. If you give a puzzle to an LLM, it will fail 100%, and this is how we're benchmarking the LLMs. Now, I want to spend a couple of words about MCP, because it's a trend, and we love trends. But I mean, jokes apart, we need to kind of, have a feeling of this MCP. MCP, in the end, is just a protocol. You can imagine of MCP as this local area network. I don't remember people getting hyped for the local area network. No one had like strikes because of a local area network, and they say that there was a huge hype around it. But with MCP, I don't know, people are really hyped. In the end, it's a protocol. It's a protocol for letting multiple agents work together. So they work in a way that they can actually communicate between them. As a local area network protocol, what we're doing is basically having these devices in the same room, and we don't think about how the USB connects to the device, because a protocol is a standard and we just have to use it. And no one tomorrow will come to you saying, hey, I have a new type of USB, now use it. No, we have a standard and we have protocols. And when it comes with standards, sometimes we fail. There are many examples where we fail, data frames in pandas and so forth, so on. Sometimes we fail, but for now this is working, it's interesting. So my take on this is have a look at MCP. It's an easy concept. It's for making agents talking between them from different libraries, different vendors. Is it something new? No. It's like talking about a contract of an API. It's not something new. All right, so you probably heard me saying agentic AI and agents. And I get these questions many times, and that's why after doing a workshop at the PyCon DE, I decided to create these slides, because someone asked me, why are you interchanging AI agents and agentic AI? The main problem is, in my mind, there is no difference, but with agentic AI, we're basically talking about a system that is designed to act towards a goal. And with AI agents, the actual units we have in it. These two examples are probably a good way to explain it. We have an agent, but then at the same time, we have this group of agents, which is an agentic AI system. It's more for labels. So you will hear these words, and it's more about standards. So what can we solve with agentic AI? This is the most important questions. I want to give a couple of examples. Remember the dynamic system. When something is dynamic, it's really complicated to create an algorithm that does exactly what you want and that it will always work. Because at some point, something will change in the dynamic system and your deterministic algorithm will fail. A couple of examples. Let's look at this planning and goal decomposition. Example, travel planner that books, rebooks, and adapts. Why is this dynamic? Because you have to go back and forth between what you get from, I don't know, the books, like let's say you want to do this travel planner that books, rebooks, adapts. You're booking something and then you're like, okay, I don't like this, I want to go somewhere else. This is above my budget. I need to go back and forth and change the initial constraints and so forth, so on. When you have all these decisions and when you have all these components that are telling you that this is an optimization problem, perhaps you can use some agents in order to avoid to write a deterministic algorithm that is failed. Let's assume you're writing an agent that is crawling the analytics video web page. At some point, if you write a deterministic algorithm, it will fail because if they change something in the page, this bot will probably fail. But the crawler, if it's an agent, can adapt to the page, and you're not telling the agent, check this HTML component, but you're just saying, I want to crawl this part, you decide how to do it as long as you give me this kind of output, and so forth, so on. Now, we're going to dive into, because I'm a builder, and apart from all this nice theory that I showed you, I want to dive into how we can do it. And you can do it also today. You can do it in a few hours. It's not a big deal. With CrewAI, this is an open source software, so open source library. This big disclaimer, I don't work for them. I contributed to the library, but I don't work for them. I just like it. I use some other libraries, LangGraph, LangChain, all of them. Tell me one library, I tried it. CrewAI is really nice because it's simple, it focuses on orchestration, it gives you a very good understanding of what an agent is, what a task is, and then what a crew is. And most of these problems, that's my take, are about orchestrating something. So you want to orchestrate agents. Who is not with me? Who is sleeping? Only me? Okay, that's good. Now, let's have a look at the architecture. So if you want to start with CrewAI, the first thing you want to know is that we work with agents. We have tasks that are basically what the agents are going to work on. And then you have this process unit, which we don't care about because it's implemented by CrewAI. You don't care about the thinking process, what we said before. The thinking process is implemented. You don't think about, okay, now I have to decide how to orchestrate stuff. No, it's implemented, it will use LLMs, and the strategy is already in the library. And then you have a crew, which is it's a team of agents, and you get an outcome. Let's have a look at what it means to work with agent and orchestrating agent. The easiest way to explain this is that you're creating a team. Whenever you want to create a team of people, let's say a marketing team, you need someone that focuses on content creation. I don't know what it takes to create a marketing team. I don't know, imaging. Maybe you need a content creation manager. You need someone who does some data analytics and so forth, so on. And they're working together as a single unit, but they all have different tasks. And this is what you do when you work with CrewAI. You create different agents that are going to work together. One agent is about checking the results. One is connecting to APIs. One is creating content, and so forth, so on. Now, let's dive into the creation of our first agent. What does it take with CrewAI to say, okay, I need one agent. I'm creating one with Python. How many lines of code do I need? On paper, we can say 1. If you format it very well, 6, I guess. And when you create an agent in CrewAI, you just use this agent class, and then you define the role, the goal, the backstory of the agent, and that's pretty much it. You probably, if you know a bit about prompt engineering, not too much if you're really bad at prompt engineering as I am, how many prompt engineers in the room? Don't be shy. It's not a bad job. No one No one answered this question. They're always like, I don't want to say it, I'm a prompt engineer. I'm a prompt engineer, I'm really proud of that. So, okay, no prompt engineers here. Prompt engineering is when you write a prompt and you send it to your LLM, and then you go on LinkedIn and say, look at this, look at what I've achieved. So jokes apart, prompt engineering is actually really interesting, and there are many ways you can optimize it. And if you look at this, you will probably see some of the stuff that we usually put into the prompt. So when we create a prompt, what do? We're like, you are a data analyst with 100 years of experience, you never missed a task, and your parents were also data analysts. This is what we do when we create a prompt. So very rude way of telling the prompt what the prompt is about. And when we do this, it's because we want to be sure that the prompt is going to achieve whatever the tasks that we want to give to the prompt, to the LLM. And probably you will see some similarities here, because what we're trying to do is exactly this. We're trying to tell the agent what the agent is about. But there's something missing here. I mean, let's say we want to go for it. We want to run this agent. Who knows what is missing? If you answer, you get a free access to all analytics video classes. There are no people from analytics video here, I guess. Execution. What do you say, class? Task, okay. Context, okay. Model, okay. All good points, because that's the first slide about CrewAI, so there are a lot of things missing yet. But the answer is the task. We're not telling the agent what to do. I mean, this is just an agent with 1,000 years of experience and a lot of relatives that are working in the data field, but it's pointless if you don't tell the agent what to do. So we need a task. This is exactly what we do with CrewAI. We have a different module for creating something that we're going to give to the agents, which is the task. Now, with this task, we're saying, you, very good data analysts, are going to work on this. And another good point, especially for the prompt engineers in the room, is this expected output. How many times you write a prompt that maybe goes in production, I don't know, and the output is completely broken? How many times you get broken outputs from your prompt? Like you say, give me a JSON, and you get a cat. Yeah, okay. I mean, my friends, prompt engineers, don't want to say anything. They don't want to show that they're in the room, but I have a lot of friends here. Yeah, the problem is that when I work with prompts, I say, give me a JSON, give me a JSON, give me a JSON, and I pray that I'm going to get a JSON and I'm going to get something else. And the whole application breaks. And this is something really nice you can do with this library. The expected output, you're telling, I want this. And the LLM, the thinking process behind, will make sure that you get that output. Even better, we will see it in an example, you can use Pydantic. Who knows Pydantic here? Okay, that's good. Pydantic is essentially for saying, I want to do data validation. I'm expecting potatoes from this, and I'm going to get potatoes. That's it. That's Pydantic in 2 words. I hope they will never find out that I explain the package like this. Then we have the crew. So we take all the stuff that we have done, because we have the agents, we have the task, and we're ready to go. We can execute anything. We put everything together. So we say, agents, these are the 2 agents we have. This is about building the team. And then we have the tasks, and we decide which process we want to use, if we want to do it in a sequential way, or if we need some kind of hierarchical approach. And then we run it. Done. We can run this crew. We'll get something out of it. We didn't talk about the LLMs, right? I didn't mention this. CrewAI is actually LLMs agnostic. It means that you can use anything. You can use ChatGPT, any vendors available is now compatible with anything. Open router, you can do whatever you want. So it's LLM agnostic. Now we have another powerful concept for agents, which is tools. Because then the agents can actually use a tool. One example, we have a crawler agent, and the agent can decide to browse the web. One good example is this researcher, marketing researcher, which can use these tools, which is Serper Dev tool. Who knows this Serper Dev tool? Have you heard of it? It's a really powerful tool. You can also get a key for free, and it will allow the agent to browse the web. And it's really powerful. What you have to do is exactly this. This is a working code. You don't need anything else. This is going to work. It's going to use a tool whenever it's needed, and that's it. A couple of more advanced features. I don't want to dive too much into this, but essentially you can play with the memory if you want to use the context memory. If you say, I want to access the memory and I want to play with it because I need a really long context and so forth, so on, you can do that. The picture on the right is actually coming from, sorry, from the left. It's coming from the inside the package. I just want to give you an overview of what this look like. On the right, we have the flow, another really interesting concept. The flow is really good for guardrails. Let's say we're creating an agent that is creating, we implemented an agent that is creating content, but then you want to be sure that this content is not about violence or things like this. Maybe you have some constraints. What you can do is implementing guardrails, and these guardrails will force the agents, the crew, to work in a specific direction. All right, now we move to the ski trip use case. That's me. You think I'm really good at skis? I'm not. This is just a very nice picture to show that I can ski, but really bad. Anyhow, I love skiing anyhow. And these are the pictures. A friend of mine, he was lying on the snow, and I put all this around him, and it looks like he's flying. But he was actually on the snow crying. The problem I had, this is something I did with CrewAI. It was really successful and helpful because when I started skiing a few years ago, I didn't know anything about skiing. Literally anything. I didn't even know where to rent my stuff. And I had all these questions, and we decided to do this, me and a couple of friends. We were all traveling from different places, and we didn't know where to rent equipment. We didn't know how to, I don't know, like, I remember we had very silly questions like, okay, if we get this renting place, if you rent something from one place, then is it going to be far away from the slope? Like many questions like this. And while working on this task, I realized that I was always going back and forth, like, okay, we found a place, but it's not good for me because I'm traveling from Hamburg. Another guy was traveling from Madrid and so forth, so on. What I did was actually using CrewAI to solve this problem because I realized that it was an optimizing problem, optimization problem. So I was like, what if I write one solution that is going to work also for the next iterations of this problem? So what if I can change the constraints and perhaps the destination and maybe get an answer also for my next trips? And this is why I decided to orchestrate this with agents. First of all, I wanted to use this for something good. I wanted to use LLMs for something that is useful because most of my LLMs projects are a big failure. And I wanted to do something scalable. That was the main reason, because what if I want to do another trip in 3 months? Do I have to start this problem from scratch, or can I just press a button and get a suggestion? And so far, so on. We start with what I implemented. This is not all the agents, just the more important ones. There are many agents indeed. So we start with the ski destination research agent. This agent is about finding the ski destination based on the cost preferences. Then we have an accommodation agent. This agent is about finding the best hotel. As you can see with this, for this agent, I have tools equal to search tool. The search tool is the separate dev tool that we saw before. The agent doesn't know how to access the web, how to browse the web if you don't tell the agent how to do. Either you implement a custom tool that does something, or you use one of the tools available, and there are many tools available. And then we have the ski rental advisor agent. This agent is for the rental shop. So it's looking for the best rental shop based on the output of the other agents. Don't forget that we're trying to orchestrate agent. It's not possible that one agent comes to me and say, hey, I found this amazing place, but it's $2,000 per night. It's not possible if this agent is saying it's too far away from the slope, or perhaps it's too expensive. And the most important agent, which is the manager. In CrewAI, you can have a specific way to orchestrate the agents. You can use an hierarchical process. The hierarchical process is telling the spatial agent that he's in charge, or she is in charge of overseeing the work of the other agents. Let's say the other agents are going completely rogue and they are suggesting things that don't work out with my budget. This agent will be, hey, I'm the manager, you're doing something wrong. Perhaps this agent has to look for another accommodation plan because it's too expensive. And this is the constraint that I'm putting into this optimization problem. The constraint is I have a budget. Be careful. And now we move to the tasks. So the first task, of course, is for the destination find, the destination agent. So here we have a specific task, which is pretty similar to the classical prompts that we're used to, that says, hey, based on, now I'm putting some business knowledge inside. Before the agent was too general, but the tasks are really close to my business domain, because I'm putting the names and the destination of the people, and I'm saying, hey, I want to go there, here, these are the names, these are the destinations, try to find something. And I give this to the agents that we saw before. I also do the same with the manager tasks, and I'm saying, hey, you're the manager, be careful to what the other agents are doing, and I have these constraints. Now we put everything together in one single crew. This crew has the agents, the tasks in it, and as a process, this time we use hierarchical. Hierarchical basically means that we have an agent manager that is overseeing the work of the other agents. The final output is this. I get a TXT out of this with a lot of information. I followed this advice. I went to Chamonix. It was bad. I didn't like it anyhow. Yeah, this was actually helpful. There were a lot of information in it. I used this also some other times. I don't know why my friends are following me in these trips recommended by AI agents. This doesn't make sense. But it was actually very useful. Now we move to final, who is not with me, by the way? I'm talking too much, right? Talking too much. Who is not with me? Okay, how many You are the only good person in this room. Probably also good good prompt engineer, right? Right? All right, jokes apart, the demo. Essentially, what we saw before is a basic take to CrewAI. Now I want to show you something that was also part of one of my courses at Analytics Video, actually. I took that, I made it like more robust, and I want to show it here. Essentially is a mock interviewer system. So you can chat with this interviewer. Let's say you want to interview at Google, and you don't know anything about the company. With this mock interviewer, you have agents do the work for you under the hood, finding the right information based on the level, whatever you want to do at Google, and it will make sure that you get good questions and you can answer the question with text and voice if you want. All right, the architecture is CrewAI, then we use OpenAI Whisper. Who knows OpenAI Whisper? Perfect is essentially for doing speech to text, so you talk and you get a text out of it. It works very, very well. And then we use Streamlit. Do you know Streamlit for building web app? All right, it's a Pythonic way to build web app in a few lines of code. And you get something beautiful out of it. The application flow. We start the interview. We get the first question. We answer it via text or vocal chat. In the meantime, we get a follow-up question as an asynchronous agent. And we continue until we want to stop this process. I don't know what's after this slide. Oops, we don't want to check that. All right, we switch to my laptop. Okay, we need to open everything again. Please don't steal secrets from my desktop. All right, so what we have here is this very simple projects that I was talking about, and I want to guide you through what I implemented in it. Here, I put everything in a notebook, hopefully. All right, we start with the imports. As we said, we're going to use CrewAI. I think I can switch to this. Can I switch to this? Does it work? Great. Can you hear me well? All right. So essentially what we have here is the agent, the tasks, the crew, and the process, things that we have seen before. What's new is, no, this is not you. You know now about separate dev tool. It's for browsing the web. Then we have some stuff from Pydantic, because we're also leveraging Pydantic in implementation. And then we have async IO, because we're going to run an agent as an asynchronous agent under the hood. All right, so first of all, with CrewAI, you can do this really nice stuff, and you can say, hey, the output of this agent is going to look like this. And when you do it, CrewAI will make sure that it's going to be like that. It's really nice because you get an output, and then you can access that output as a struct. I don't know if you're familiar with C, as a dictionary, not a struct. The first crew is about preparing the information we need to create the questions. So we're going to have an agent that is in charge of collecting the company information. This is the agent. And then we're going to have an agent that is in charge of creating the question. So let's say you want to interview at Google, and then the agent is going to look for all the information about the company and your position. And then the second agent will take this information and will create the first question. This agent, of course, is able to access the web because we have search tool, which is our separate dev tool. This agent doesn't need any access to the browser. This is arguable, by the way. You can decide how to implement this agent. Now we move to the tasks. With the task, we have, for this first crew, because we're implementing 2 crews, the first task is the task for looking for the company information. And then we have one for the question preparation. So we get we get all the company name, the role, the difficulty. We inject it into the description of the task. We do the same for the question, because the question, when we create it, we want to decide the difficulty of the question and so forth, so on. You will get this code, we'll put it on GitHub for free. And then we have a second crew, which is about evaluating the answer. So the first crew is working towards the creation of the question, and then we get another crew that is evaluating what you're giving as an answer. This crew will get your question, so these 2 agents are about getting your question, and it will also create a follow-up question. The nice thing about this crew is that we're gonna do it asynchronously, and we will see what I mean. The 2 tasks that we have for these agents are evaluating the question, so we get the question that we created, the user answer, the correct answer, because we also generated that in the first step. We put everything together and we see if it works, if we see that if your question is actually correct, and you get a feedback out of it. Then, with the create follow-up question tasks, in the meantime, under the hood, asynchronously, so you don't have to block the execution of your software, of your program, or your code, we are creating a second question. So while you're working on it, you don't care about calling the LLM, doing all this expensive stuff because it's happening under the hood. Then we move on, we assemble the crew. We have the first crew, initialize preparation crew. This crew, as we say, is about creating the questions and so forth, so on. And then we have the evaluation crew, which is about evaluating. In addition to this, we have another crew, which is the generate follow-up crew. As you can see, this is an asynchronous crew. And also, when we call this crew with CrewAI, we don't use it kickoff, but we use it kickoff async function. So it calls this function as an asynchronous function. Now we look, sorry, I'm trying to kill this mosquito, but it's away. Now we try to execute. Usually, fortunately, I have a readme here. All right. Now we run the Streamlit. I'm not showing you the Streamlit code. Is boring, and you will get it anyhow. We just do one single run. All right. So this is what it looks like. This is a Streamlit application. All the credits for the beautiness of this go to Streamlit. Let's say I want to interview at Google, software engineer, meet hard. All right, we start the interview. Now it takes a while. That's why, as you can imagine, I have this asynchronous agent working under the hood, because the problem is that it takes a while to send the request to the LLM and so far so on. So what I'm doing here is, okay, I prepare the first question, it takes a while, but I won't see this process again, because under the hood I'm preparing the second one once I get the first. And this process goes over and over, and you're not waiting. Okay, the first question takes a bit. We wait, we have 1 minute left. But I will get 10 more, no worries. I will get 10 more. I mean, I came all over from Germany. I don't want to be beaten by a timer. All right, so the question, I don't know what it's about. It's like, I'm sorry, ask Miguel or Josh. This is, of course, the wrong answer. I don't think they know the answer anyhow. Yeah, we're getting the evaluation. If we look at the output of what is going on here, the agents are thinking, and you get a very verbose overview of what is happening. And now, as you see, we already got the second question, because the second question was prepared under the hood as an asynchronous question. And that's pretty much it. I will give you access to this repository. You can run it, you can modify it, you can make it better, and it's yours. All right, so now we move back to the slides. I will definitely steal more minutes if it's fine for you. Hello? Yeah. And after seeing all this stuff, I hope that you will work on agents from now on. I want to share a couple of learnings. The first one is that I love this modular approach from CrewAI. You have models, you can reuse it. You want to work on tools. I think that the data scientists are not going to implement prompts and agents. They're going to work on tools that are going to be used by the agents. This is what you're going to do probably. You have a lot of hidden complexity, which is good and bad, because I'm a contributor, I know how to look into this repository, but it can be complicated, and there are bugs sometimes. This is an open source software, and it's quite new. You have to accept the framework way, right? They do stuff in this way, either you like it or not, it is what it is. It's community driven, and it's a really low code approach, way better than LangGraph for some problems. It depends. And I will answer more questions, because now I'm going to have the Q&A, so you can come over and ask me as many questions as you want. We're really running out of time. As you can see, the lady is going to kick me out. Please, 1 minute. No, just kidding. I'm done. Thank you. I hope you had fun. I'll be here for 3 more days. Thank you again.